Okay, welcome back to this back-to-back lightning talk session from Core Development Group. We had in the previous session the kernel working group lightning talks and also the security ones. We're going to have in this one power management working group, the virtualization engineering team, and a couple of topics that we are working on core development. First of all, you are seeing here developers talking about what they're doing. Obviously, they are representing a team, and that team is not just obviously Linaro employees, several of them mentioned them, but assignees that do a great job for us, and in some cases, outstanding, I would say outstanding job. Okay, so let's start with power management, and yeah, the Linaro Power Management Working Group does something beyond EAS. In this case, SOC Eileen and Ulf Hansson is going to be again in the stage to tell us what are we doing in this area.
Thanks. Okay, hello everybody. So yeah, we do something else besides CAS actually, and the recent accomplishments in this area is that a while ago we realized that there wasn't any good reference implementation of how to deploy runtime and system PM on a SOC. So we wanted to make sure to fix this. And along the road, we realized that there were some corner cases. For you that has been attending Linaro Connects before has probably noticed a few speeches from Kevin that he had around problems with having system PM and runtime PM work together. And some of those corner cases we bumped into quite fast, and we tried to resolve those. And besides that, we also looked into using the generic power domain, so we could get rid of as much SOC. We only wanted SOC-specific code, so the rest should be common. And that's why we wanted to use the generic power domain. And looking into that, we realized it needed some attention, so we tried to do some modernizing and improving it. So we ended up recently to saying that UX500 and Exynos SOCs is pretty good references for how to deal with these things. So they have enabled the YMPD, as we also call generic power domain, and they have runtime PM implemented and system PM implemented. So what we are thinking of right now is CPU idle for multi-cluster SOCs. And currently CPU idle is, as I say here, about the CPU, not the clusters. And we have some, the scenarios today is that we have, like in OMAP4 and Tegra, we have at least coupled idle states. And we have the MCPM and the SOC-specific backend drivers, which shows how it looks like today. And what we would like to have tomorrow is we would like to have, we'll say something that we call idle core. Where it is, that's not the important thing right now, but we want something that we call SMP, HMP awareness in this part. And in principle, it's about controlling the CPUs, clusters, and shared caches and interconnects. So we want to reduce the SOC-specific code by doing this. And how to reach that goal? We have some ideas, which we have been discussing with various PM maintainers, and they are supporting this kind of ideas that I'm going to describe really shortly here. In principle, we want to use the generic power domain. And what the generic power domain provides us is that it can group devices into domains, and it can be nested. And GenPD is completely built upon runtime PM, and when a domain is power off, that's controlled through the runtime PM framework. And that's in principle those kind of features that we could benefit from. Going for this approach, we will have some challenges, and especially the hardest part will definitely be to fix the GenPD's locking mechanism, because it hasn't been designed to deal with atomic contexts. So that's one thing that we're looking into. Another important thing is there are some latency issues for the generic power domain, which we'd like to look into as well. Then long-term wise, this should probably be a lot of other bullets that is missing, but we're trying to make up some long-term goals of what we want to work on in this area. But one really important thing that we think is that we want to simplify for drivers and other subsystems to deploy runtime PM and system PM support. But there is probably a lot of other things that should fall into this area as well. So we're looking into that during this week, what we should put in here as well. Okay, that's it.
Thank you. Yeah, great ideas going on in this area, so feel free to meet Ulf or Kevin Hillman, which is here also, and talked about this. We were joking a little bit before about EAS. As you know, it's one of the, I don't know, top 2, top 3 topics for Linaro overall, and obviously for the power management working group. This is something that we are doing with ARM. And, well, we have a common vision, ARM and Linaro, about this. And since we are approaching the final stages of the development, we also have now a common roadmap and a clear idea of what we are going to do the following months. So we are going to describe a little bit the Linaro side of the story, which is basically what we are doing. So please, Mike, go ahead.
Sure. Thanks. Hi, everybody. So for those of you that don't know, EAS stands for the Energy Aware Scheduler, or Energy Aware Scheduling work. And it's a set of features that are being worked on by Linaro and ARM to improve energy consumption with a focus around interactions that happen with the Linux kernel scheduler. The scheduler is the decision-making component that often has the best set of statistics and the best view to make some of these decisions. So some recent accomplishments is that some benchmark improvements. If you see that CFS, by the way, that stands for the Completely Fair Scheduler. So we've merged infrastructure changes and some improvements to CFS. I encourage you to take a look at the Git log there. And what you'll find are benchmark improvements, optimizations, bug fixes, and maybe most importantly, some foundational work which has been laid down and some of it merged upstream that we'll use as the basis for further EAS development. Additionally, there's tighter integration between CPU idle and the scheduler, and what this mostly boils down to is better sharing of statistics between the CPU idle subsystem and what the scheduler knows. And I'll come back to this on a future slide because it also lays the groundwork for some other work. Another thing that we've been working on, Daniel Lescano proved a really cool improvement to idle interrupt prediction. And what this does is this improves on what the menu governor can do. And so Daniel's original idea was to track interrupt latencies on a per task basis, and he has some really interesting data that shows that it certainly improves upon what the menu governor thinks is going to happen in the future. And also there's been a demo or some code released on LKML that shows the CPU frequency selection proof of concept. And this is somewhat analogous. It's where the scheduler itself tries to set the CPU frequency that you should be running at. And this is kind of cool because in the past, for those of you that have worked with CPU Freak before, you know that CPU Freak is its own subsystem, and it doesn't really coordinate very well with the scheduler at all. The scheduler may be migrating tasks away from a CPU at the same time that CPU Freak decides to make that CPU run fast. It can be very inefficient. So we've shown that the two can be unified. And then additionally, a big accomplishment is some improved collaboration between the developers that are hacking on EAS. I mean, this is a multidisciplinary, multi-company approach. And in particular, in 2014, ARM and Linaro worked very hard to coordinate the patch submissions. You know, we're touching a lot of the same pieces of code, stepping on each other's toes. And so in an effort to make it easier for developers, you know, we had a lot of face-to-face meetings at conferences, figured out what the dependencies are, worked that out ahead of time so that our patch submissions are nice and coherent. And that was a big step forward. So some of the work in progress that we have, Vincent, his CPU capacity rework patches are on LKML. We'd love to see those merge soon. And for those of you that are interested in this area, I encourage you to go check them out on LKML. Of course, give it your ACK immediately. And then I mentioned Daniel's improved interrupt prediction work. That's after some feedback at LPC in Dusseldorf. It was decided that the mechanism, that the idea of improving upon interrupt prediction was good, and his numbers were certainly good. But the mechanism should be per device interrupt tracking instead of per task, and so he's currently in the process of evolving that design. We're also doing experiments with combining task placement on CPUs with CPU frequency selection, and this is something I'm working on that I think is very, very cool. You know, as I mentioned earlier, CPU Freak doesn't really coordinate very well with the scheduler, and it's a bit of a holy grail for those two to be unified, where you have one decision-making point that really knows what it's doing in terms of placing tasks on CPUs and scaling the capacity through CPU frequency changes. There's also been patches for the unifying the idle task behavior, and this is interesting that there's slightly different behaviors across architectures in CPU idle, and there's no reason for those differences to exist. So Daniel and some others have worked on basically unifying that behavior so that it's coherent, as well as there's, if you are familiar with the CPU Freak DT driver, which is like a nice generic CPU Freak driver where you supply some DT data and it just works. Daniel's also been working on something analogous for CPU idle, where it's device tree driven. There'll be an ARM 32-bit version and an ARM 64 version of that driver. So the next steps for us, a big one is to characterize power and performance. So we work a lot on making these features, actually getting the feature written and getting it out there on the list for people to take a look at. But the big thing is, there's so many different corner cases, there's so many different workloads, there's different targets, Android and Chrome and everything else, server workloads, et cetera, that we really have to characterize the power and performance. And the backports are interesting here because it will enable Linaro and ARM and the members to take this work and actually try it on their products. And we can only run so many benchmarks and tests, though we like to run as many as we can. We want to enable the members to be able to do that as well. They have the benchmarks that are near and dear to their heart, and they also have their own stuff internally, and we want to empower them to be able to test it. And then, of course, we have to iterate patches on the list. We have stuff that's out there, stuff that needs to be refreshed, or stuff where we need to ping key people to get their the review and their ACK on it. That work never stops. And also this week, we're really excited to discuss this stuff with you. There's a lot of heuristics, kind of algorithms, and policies that we'd like feedback as much as possible. So please do find us in the hacking room. We're happy to talk about this stuff. We have blocks. In particular, on Thursday, we have a big EAS session blocked out. And then finally, our job is not done until it's merged upstream. So that's the goal. So are we taking questions now, or are we doing it later on? OK, cool. All right, well, thank you.
And, well, we are working basically on the development side, but in order to try to make everything that we are doing currently developing upstream available for members, so members can test it and validate it. Not just members, because it's a public tree, but obviously we care a little bit more about members than non-members. But in order to make all this work available for them to port it to their own platforms and validate it and test it and provide us feedback, We are doing a lot of backporting and integration with ARM, both of us together, all the code that we have been working on the last, well, years, I would say. And it's ready. He's going to talk about that work, and I will provide some information for those of you who are more interested in this topic. Where can you meet us during the week? Alex, thank you.
Thank you. Good afternoon, everyone. I'm Alex Shi from Linaro Stable Kernel team. Okay. From last connection, we started the backporting, the EAS, just like the makers introduced. That is energy-aware scheduling. Yeah. Well, the most work we ported from the upstream kernel to the 3.10 kernel, which kernel is used widely in the Android world and also on the ARM devices. The several main features included, like Vincent did CPU topology changes, which introduce power domain in the scheduler domain. And the second is CPU-aware scheduling, which done by Daniel and Nico. That's part mainly where it will pick up the best idle CPU when working out tasks. That's save lots of power. The third would be ARM's ND model. That's also the core of the EAS. This backporting was done by JIRA from ARM. And we also cherry pick much of and small some scheduling optimizations. Work in progress. We are regularly doing the smoking testing in our Lava lab. Currently we just run it on the TC2 board, also on the Panda board. And Larry is doing something to testing the EAS basic functional. Yeah. The work for the next steps. Yeah. We are talking how to maintain, how to organize the bank tree well, the backporting tree better. And we will keep, just like Mike introduced some lots of interesting features will be added into the scheduler for the power saving. All the new features is our target to do the backporting, not only from the upstream kernel, but also maybe for non-upstream tree. And the third, I'd like to encourage our member company to use this kind of EAS backported tree to your own to your own platform, to your own boards. And we'd like to hear from you for any testing result, from any feedback, and we would like to consider any suggestion in our future backporting. That's all. Thank you.
Thank you, Alex. Before we go into the questions, for those of you who are Linaro members, on Thursday morning, we have a meeting in which ARM and Linaro will provide the whole picture of a story and some details about what is coming. And we will talk a little bit more there on a training session that we have ready for members on Thursday afternoon, in which we're going to try to teach and also learn a little bit of your experience. We're going to try to teach how to use this tree and how can we help you to port all this code to your platform so you can test it and benchmark it and create a feedback loop with us, so we can reinforce our ideas with your numbers in your own platforms. That is coming on Thursday. Okay, so now let's open a little bit again, I think before we go to the question, I think that the interesting idea about Thursday meeting is that you're going to see the whole picture, not just what we have talked here, which is basically what we have done, right, which is just part of a puzzle. Questions for anything related with the power management working group or the LSK work? Can somebody handle the microphone over there? Thank you, Alex.
Is this on? Okay. I've recently started doing some work with core isolation and operating individual cores in full tickless mode, and I wondered, it occurred to me that if you are completely removing the scheduler activities from a particular core, that you may actually wind up essentially cooking the core with CPU-intensive application. So I was curious as to whether you guys in your energy-aware scheduler have taken full tickless operation into account, and if so, how those two might interact with one another.
So your basic concern is that you've completely isolated a core and you have some workload running on it, but you're worried about thermal issues with it or something like that?
Yes.
Oh, okay. Well, I'm not an expert on this topic, but I mean, I assume that whatever you're running on whatever workload you're running on that core might need to take that into account, right? I mean, I guess it's possible if you have a thermal framework or something going that you could still monitor a thermal sensor near that core, and then it could intervene in the event of a thermal event or crossing some threshold.
So if I understand your answer, the gist of it is that it's on the application writer to take care of it if you are running in full tickless mode and not interacting with the scheduler.
Not exactly. What I mean to say is if you have something running on the other cores that's monitoring, let's say, a thermal sensor or something, and it trips, then I guess you could intervene without the application-specific code on your isolated core having to know about it. But I would say that that's not exactly related to the EAS work, right? That's more of a thermal framework issue, you know, and there's a couple of different solutions for that out there. But I would say that the EAS stuff, we haven't yet to look at like the isolated core case. So.
Okay.
Any further question? No? Okay, let's move on then. Let's talk now about what we are doing in the virtualization area. And we have Alex Bernie. Yeah, you see Christopher Dahl, but he's sick. Yeah, he got a cold in Europe and brought it here and grew. So Alex is in his team, so he will provide a lightning talk. Thank you.
So any errors and omissions are purely mine. So yeah, the work that we've done in the last 6 to 8 months, we've done some enablement work on getting support for guests running UEFI, thanks to our friends in LEG. We've got guest migration working for V8 KVM. There's a couple of patches still in flight for that, but it's basically done. Dirty page logging is a prerequisite for doing live migrations, so that's migrations where you want to migrate as much of the machine state as you want before you suspend it. Also, Git v3 support has gone in, as well as the usual fixes and improvements. So stuff that we're currently working on, we're doing more work to bring us into compliance with the VM spec. So that's more for UEFI, PCI Express is coming, as well as hot plug and ACPI work. Guest debug, so you can debug your guests as they run. The first version of the patch is out and it works. And it's now going through its iterations on the mailing list before it gets accepted upstream. We're doing some work on device pass-through, so you can assign devices directly to your VMs. There's also some work on IRQ forwarding to reduce the load of IRQs and performance monitor support. And then coming up, we're continuing to build and improve our test infrastructure. We want to be able to defend as much of the KVM functionality as possible as the tree progresses, so we detect regressions quickly. And along with that, we'd like to increase the amount of performance measurement we do and optimizations. There's also going to be specific support for cross-CPU types, so big little systems, and then the PCIe pass-through, which I've already mentioned. And finally, the last bit of work that's likely to be quite interesting is for the ARM v8.1, which offers some interesting optimizations for the way that we handle the hypervisor, which should give us a good boost in performance. There you go.
Thank you, Alex. Good job. Peter, you're the next one.
Hi there. So I'm Peter Maydell. I work on QEMU for Linaro. I'm also one of QEMU's upstream maintainers, so I've included 1 or 2 points in these slides which are work done by the community in general that Linaro has an interest in, even though we haven't necessarily done the bulk of the work for them. So yeah, starting with what we've done recently, Android emulator. This was a big piece of work, so Greg and Alex did a lot of work on this. I did a few bits. And so the old classic Android emulator that Google have shipped forever is based on a really old version of QEMU, so it didn't have 64-bit support. It was getting a bit rotty around the edges. So we basically got something that will run Android on a modern version of QEMU that's got 64-bit support, has much fewer changes against QEMU mainline. And Google have then taken that and they've added their 3D emulation support, and we're told that should get into the SDK Studio 1.2. So I think that's great news. What else have we done? We've done a lot of work on Trust Zone. So QEMU now supports the Trust Zone in the CPU emulation itself. So that's 32-bit only, but that's still good enough. You can run OptTEE with that. And we're obviously working on the bits that are missing. And we've also got debug architecture emulation, breakpoints, watch points, single stepping. So what this means is you can have a 64-bit guest running in your emulator, and you can run GDB and it will actually work. For V7, you didn't need to emulate all of this because GDB and the kernel will work even without any hardware support. But because V8 mandates the debug architecture, GDB and the kernel rely on it, so we have to have it in the emulator. Right, what are we working on at the moment? So TCG multi-threading, this is a big piece of work, and it's basically aimed at improving our performance for emulating SMP guests. At the moment, QEMU, even if you're emulating a 4-core guest, we will do all of that work on a single host thread, and we will just round robin between all the guests on that one thread. Obviously, what you want to do is lots of host threads, one host thread per guest core, but trying to retrofit that into the design is really quite a lot of work. This is mostly being done by a company called GreenSock, so they're kind of leading the effort. We're providing sort of design suggestions and code review at the moment. We may take a more active part in that later. We'll see. Next up is PCIe emulation. This is something we've wanted for ages. It's been probably a year we've said, yes, we really must do PCIe emulation. Alex Graff from SUSE has stepped up and done that work, and it's actually pretty much done, so it should go upstream probably within a week or two. And finally, yep, so I said Trust Zone, more stuff, 64-bit support for peripherals that know about Trust Zone, mostly that's the interrupt controller, and generally filling in the gaps that we haven't done yet. And finally, kind of the top of our to-do list, these are things we haven't started yet, but they're pretty high on the list. GIC v3 support, so we must support when the kernel for KVM has GIC v3, we want to at least allow, when you're using QEMU as the user space control for KVM, we want that GIC v3 to work. We also would like to have a fully emulated GIC v3 so that you can run guests that assume they have a v3 GIC within QEMU's emulation, that is going to be a lot of work because the Geek v3 is markedly more complicated than V2. And finally, number 3, we'd like to kind of bring together the work we did on the Android emulator and the work we've been doing with TrustZone to produce kind of a prototype of a system where you can run OptIE and Android as the non-trusted guest and kind of demonstrate that you can have emulated Android and something within your emulated Android space makes requests through to OptIE. And finally, threading support for user mode emulation, which is another thing that's been on our wish list forever. At the moment, QEMU's user mode support, we just say, do not try and run threaded guests because it won't work. Hopefully the support for multi-threaded TCG will basically fix all the bugs which are causing this to not work, and that will certainly make the GCC and toolchain testing guys happy. Yep, so those are kind of probably what we're going to be doing next. We might change the priorities, but that's probably likely to be it. Okay, thank you.
Okay. Before Julian and Barth comes out, I just want to remind you that in Linaro we have a blog called Core Dump. You can find it in the blog sections of the Linaro website, in which our teams regularly write about what they're doing. So if you don't have that in your RSS or in your list of must read, I recommend you to do it. Go ahead. And Julian and Parth are going to talk about the work we are currently doing on Zen. Thank you, guys.
Okay. So since the last Connect in September in the US, we did pretty much a lot of work on Zen to bring up new hardware, such as the AMD Seattle boards, which is our NARM64 servers. We also did some, Parth did some work to bring up Zen on ACPI, so we are able to start Zen with ACPI on using ACPI in DOM0. So DOM0 is the main domain starting on Zen. The last things, one of the last things is we did the UEFI boot support, so we are able to run Zen on UEFI, so we can start UEFI, then start Zen, and start all the guests after. On the last one, but not the least, is we released Zen 4.5 in January. So Zen 4.5 is one of the major version with a lot of feature on ARM. So we had a parity feature with x86, so we can do the same thing on x86 and on ARM. We also have Geek v3 support. Lot of memory supported, 5 terabytes for the guest, etc. You can go on the wiki page on Zen and see what's going on and what is the new features in Zen. So actually we're working on upstreaming ACPI. So as we have a prototype on ACPI, we want to have it on upstream by as soon as possible to get it maybe on Zen 4.6. The other thing is like, with ACPI, we had to create a new table for SMMU. So SMMU is not described as ACPI, so we were working on creating specification for that. It's the same thing for Zen. We have to give some information from Zen to the guest. So we were working with various companies to create a specification to say, I want that for them. Also, Linaro has done some work to be able to boot UEFI in the guest. So as the guest is completely different as a normal operating system, we have some drivers specific for Zen. We added support of these drivers in UEFI in order to use UEFI. We were also working as adding support for platform device password, so being able to give the network card from the SOC directly to the guest, so he can using it on avoiding to use virtualized driver. The last thing is adding support for Big Indian, so we are able to use Big Indian network software inside different guests, or even starting DOM0 with Big Indian. on also adding new support of new hardware like Cavium, improving the actual supports on etc. So that's what we were working on. Know that we have a long list of new features to add, like PCI pass-through, gig v2m, save restore, so being able to migrate one guest from one server to another servers for like migrations, adding 64K support for ARM64, and also adding emulating the different registers, like the debug registers on performance monitors registers. That's basically what we have to do on then the next few months, few years. Thank you.
Okay. Any question for any of the guys from the virtualization team? Can somebody please handle the microphone over there?
Question for QEMU. I remember that once it was possible to emulate some custom hardware on QEMU, and GreenSox in particular done some work how to plug in System C model to QEMU. Do you have follow-up on this?
So System C integration has been one of those things that, so as you say, GreenSox had that out-of-tree code. There's no support in it in upstream mainline QEMU. My take on it is that it's too far out of the mainstream of what people are trying to do with upstream QEMU. So upstream QEMU is primarily working with KVM and emulation of complete systems. And there isn't really there's not a great deal of interest in the upstream community for letting people plug in their random custom device models. So I think that your best bet for that kind of thing is going to be get companies like GreenSox to maintain that kind of thing out of tree.
Because actually it might be of great interest for writing drivers to not yet released hardware.
Yeah, I can see the use cases, but in terms of sort of the feedback we've been getting from member companies and what I see in the rest of the upstream QEMU community, it's just not there as because we'll be adding a big new thing to what QEMU is trying to do, a big new use case, and that kind of thing, it requires a long-term engagement with the rest of upstream to say this is worth doing. We can do it within the design of QEMU, and it doesn't break all the existing use cases. So it would be a lot of effort to get that in, and nobody else out there that I've seen has been prepared to put in that effort, and I have not been getting feedback from our members that says that's something that they want Linaro to spend the time on. So that's kind of my take on it.
Okay, thank you.
Any other question related with virtualization? Let's move on then. Other topics. We have 2 more lightning talks to go about 2 things that I think you're going to find interesting. And the first one is a project manager in core development, Serge Broslaski, and he's going to talk about some work that he's been doing lately and that he's going to show in a training session, right, at Connect? Okay. On Wednesday.
Yeah, so hi everyone. My name is Serge, and first, before I tell you about JIC, I will tell you why. So we are using JIRA in Linaro, and we as a management team are expecting our engineers to keep JIRA up to date. Well, luckily, all the majority of the development under Linux is done from the, command line. So this should be a tool which is suitable for our engineers, which would provide means to deal with JIRA. So that was the motivation behind this tool. So far, what we have there is full support for read-only operations, basic issue creation and editing support. Recently, there was one first contribution from the community, from outside of Linaro, support for keyring, and partial support for offline mode. So the fifth item, TBA, I was planning to work on the plane while I was flying here. I failed it, sorry. But I'm planning to work on all this stuff at Connect, and I'm doing that already. So I'm planning to add complete support. Sorry, this is what I'm planning to do in the future, not at Connect. So complete support for issue creation and editing, reporting framework, which would enable getting such reports which are not possible with standard JIRA. And one of those is like weekly activities for any engineer. Would be a nice tool to generate weekly report based on JIRA activities. Templating framework to allow customization of the output, and proper porcelain, so like high-level command set, which I'm planning to work on at Connect, as well as, if I have enough time for that, engineer's weekly report I mentioned earlier. So the role model for Jig is Git. So quite many terms you hear are matching what you know about Git. So porcelain means high level, plumbing means low level. And next steps would be finishing documentation. Currently it's lacking quite a bit of love. Also ensuring that the wiki describes everything. Creation of reports, which are missing completely at the moment. Adding support for issue lists, a bit of explanation what it means. Quite often we have to work with JIRA issues without leaving traces there, like discussing some issues, or maybe creating lists of issues which we need to work on. And for that, we need to create some spreadsheets, track them there, which is not very convenient. So this is a feature which would allow doing that right within the tool. And also full support for offline editing, which is currently also missing. So that's it. Thank you.
Okay, so, yep, the training.
Apologies, one last thing. On Wednesday, there will be a session which is called a training session, but basically that's like hands-on hacking kind of session. So if you are interested in seeing what Jig is and learning how to install and use it, you're welcome. Thank you.
Okay, the idea clearly on the tool is to make sure that the developers do not have to change their workflow and still are able to populate the tool in which we coordinate with other groups and other teams that do not work upstream. So we try to fix the challenge of matching both worlds. Let's see, it's a very interesting problem to solve. And Kevin is the last one, so he will talk a little bit about, well, I wouldn't call it personal anymore, it's getting too big. So, about his project, that we are, by the way, making good use of it.
Right, so my name's Kevin Hillman. I'm a kernel developer in the Power Management Working Group, but one of the things I also do is upstream, I help maintain the ARM SoC, a subsystem. And if you saw Arn's talk from earlier, you saw how many hundreds of platforms that are being supported there. So one of the problems with ARM SoC is there's just piles of boards, piles of SoCs, and there's not that much actual testing going on, especially on the upstream, the bleeding edge kernels. So when I've been helping with ARM-SOC, one of the things we wanted to have was some sort of easy, kind of quick early detection system when people are submitting their code upstream and inadvertently breaking other people's platforms and so on. So this slide just shows, or the image just shows kind of the line on the top there is the number of basically machines or machine types that are supported in the kernel starting at v3.0 kernel. And the lines kind of going up, the steep one is basically the number of device trees supporting the number of board file device trees there are. And the bottom one is the number of kind of DT machine start entries, which essentially means the number of SOC types. So you can see that starting at v3.0, before we really ventured into device tree land, of course there wasn't many device trees, but now we're already up over 500 device tree board files actually in the mainline kernel. So there's over 500 boards, there's approaching 100 different SOC family types that are actually being supported in mainline. And it's not uncommon for people to check stuff in and make a fix to a driver or change a driver and break somebody else's stuff because they didn't think about it. And we're seeing that a lot, and so we wanted a way to actually find that and check that easily. So when I first started this, being ARM-SOC maintainer, the kind of primary audience I had in mind was all the people that are the maintainers of their individual platforms or individual boards. So I wanted to be able to say very quickly if they merged something, or if they were about to merge something, we could run it through a test and actually get kind of a basic sanity check that their stuff was working. So what I did at the time I had a handful of boards from various places that I've worked, and I've been collecting more and more, and so as soon as I started publishing this, I had about 20 boards, and when I started publishing it, people really liked it and started sending me more boards. So now I'm up to like 50 boards. So there's 19 different SOCs, 50 different boards. And what it's testing, it's essentially anytime there's a new version of mainline, Linux Next, Stable Tree, LSK, and a couple other experimental trees, it essentially will build that and boot it across all these boards and publish essentially a boot test results to this mailing list here. So that's doing a whole bunch of different def configs as well. It's doing basically the SOC specific def configs, but also the multi-arch def config, multi-v7 def config, and some configs with a few options. So that's why there's, with 50 boards, there's almost 150 different boots that happen for every kernel across all these different boards. So those results are kind of summarized and sent to the mailing list. And if something does break, you usually get a mail from me. I'll usually bisect it or report it, at least to, even if I don't bisect it, I'll at least make sure that the maintainer of that board knows about it, or the maintainer of that subsystem knows about it. I will often bisect it as well and then report it to the patch author that broke things. So but the bisecting and reporting bit is manual at this point. That's a picture of the shelves in my board farm. It's a little bit cut off, but what's cut off is basically just more messy wires. So what's going on now? So this, like I said, this kind of started as my project for helping the upstream maintainers basically have a kind of early warning system. But in the last year or so and going forward, I've been working closely with the Linaro Lava team on this. And so these are some of the things that are in progress right now. So we're combining my results with other board farms in Linaro and kind of pushing all the results in a kind of unified form into a big database. And then we have a web dashboard and for all these results that you can get the logs and you can actually make searches and so on. Later this week, the Lava team actually has a talk on this, upstream kernel CI talk that's in the schedule. So if you're interested in this stuff, definitely come to that talk where they'll actually we'll go into more details about this web interface that's in progress. So yeah, that dashboard can take input from anybody's board farm. Right now it's taking from mine and Tyler's and a couple of the boards out of the Lava Lab in Cambridge. Right now, our stuff is mainly just doing kernel boot testing, but what we're in the process of adding is more the ability to just run any sort of tests and report results. The kernel itself is growing a handful of self-tests that are built right into the kernel. And then there's also, of course, any other external test suites you can imagine. So yeah, in the Lava talk later this week, we'll go into more details on all the other stuff that's happening. But one of the big ones is we're working on how to automate the bisection of some of these build and boot failures. So that's kind of a harder problem. But so that's basically it, I think. Yeah.
It's an awesome project. Thank you. Any question for the last two speakers? Okay, then again, this is the effort of not just the speakers, but also 4 teams behind that I'm very proud of being responsible for, especially the incredible amount of talent that we have. And thank you all, and I hope you enjoy the rest of the week.